To Algebra 2, Lesson 2-7, Example 5, using a system to solve an equation. Solve the equation x squared plus 9x minus 5 is equal to 4 minus 3x by writing a linear quadratic system and using the intersection feature of a graphing calculator to solve it. So the system you can see is the two different expressions, right? So you're gonna make each of them into equations and graph y equals x squared plus 9x minus 5 and y equals 4 minus 3x. You can use the Desmos calculator if you don't have a graphing calculator. So here we're going to graph y is equal to x squared plus 9x minus 5 and y is equal to 4 minus 3x. And if you zoom out, you will see a nice little graph in Desmos. And if you click the intersection points, you'll be able to tell, but make sure that the intersection point is clicked correctly, because you'll also see the y-intercepts and x-intercepts that are really close to each other. And the intersection point here is like this as well. So obviously your intersection points are not going to be a nice little whole number, and so in this case it's better to use graphing technology to figure out your answers. And so yeah, your questions, your problems will tell you if you can use the graphing calculator or not. So in this case you will, and if you graph the system, you will see that your lines are going to intersect around 0.71 and negative 12.71. And so you can substitute by just substituting your values and then checking for your answers and solutions and see if it's approximately similar and if it's reasonable, right? So if you plug in 0.71 into the equation, then you want a close number. Obviously these are rounded up and your decimals aren't exact, but if you plug in 0.71 into both equations, you should get a pretty close number where it's not too different. So if it's more than 0.5 different away to each other, then I would say that's too much. So for negative 12.71 as well, if you plug it in and check your solutions, it's pretty close enough. So the equations show that the approximate solutions are reasonable. So example 5 is a really easy one. You just use graphing technology, plug it in, and solve for the intersection points. If you have TI-84 models, then you would plug in first the equations, and then you will find the intersect button, or you'll find the calc button. Yeah, depending on your model, and then you will calculate the intersection point, and then you just have to click twice for each of your lines, and you'll be able to see that the calculator gives you the solutions for these 2 points. Okay, so that's for TI-84, but if you are able to use Desmos and you're allowed to use them, then you can use them. All right, let's look at try number 5. See if you can use your technology to solve this equation by writing a linear quadratic system and solving using the intersection feature of a graphing calculator if you have a TI-84. All right, so pause the video and come back when you're ready for answers. Okay, are you ready? Yeah, what do you get when you graph them? So let's look at Desmos. I'm gonna delete these. Let's write the system of equation 3x squared minus 7x plus 4, and y is equal to 9 minus 2x. And then you can hover over your mouse if you're using Desmos. Your x is about 2.37 and negative 0.703. right? So those are your solutions. Your points of intersections are approximately these. So your solutions would be your x, because you're solving for the x variables, right? You just added y because you wanted to solve by graphing method. So you're going to describe that the points of intersection are approximately, you need to write approximately or about, so you know it's not an exact solution, okay? And 2.37 comma 4.26, right? So the solutions are about I can't write a squiggly emoji here, so let me draw them. So the solutions are x is approximately negative 0.70, wow, 70, and approximately 2.37. Okay? All right, that's it. Let's wrap up our lesson through the concept summary. So the key features of linear quadratic systems would be either, no solution, one solution, and two solutions, right? When they intersect, then that's their solutions. So you can either use substitution or elimination. We didn't really look at elimination, but you already know the process of elimination, right? So if you can use that to eliminate a variable, you can use elimination method. And if you have inequalities, though, for linear and quadratic systems, you would graph them accordingly and shade them accordingly, and make sure the graph is solid or dotted depending on your inequality sign, and you shade above or below your graph when your y is greater than or less than your equation. Okay, so that was lesson 2-7. We'll continue with the next lesson in the next video. Bye, thanks for watching.